Hi everybody. We are going to talk about how to multiply monomials today. So with every operation that we do with monomials, there's a different rule. Thankfully with adding and subtracting, those had the same rule, which was to add or subtract the coefficients and to keep your variable and exponents the same. With multiplying, the rule is different. So what I'm going to show you first of all is in this example here at the top, it says, how can we expand x to the fifth times x to the third? So what that really looks like in expanded notation, x to the fifth is x times x times x times x times x times x to the third, x times x times x. So if I were to change that back into exponential notation, this equals x to the eighth power. So what's the rule? The rule is that we are going to be adding the exponents when we are multiplying. Okay, now if there was a coefficient there, we would just be multiplying the coefficients. So that's easy. Okay, so you can see how this might start to get a little confusing with all these different rules. So it's important that you keep this straight. So again, when we're multiplying monomials, we multiply the coefficients and we add the exponents. Okay, so if you look at example 1, the coefficients here are both 1s. That's why they're not written. So if I were to multiply the coefficients, I would still get 1. So I don't really need to worry about writing that. But if I multiply x squared times x to the third, I'm going to get x to the fifth because I add my exponents. Okay, and number 2, same thing. Our coefficients are all 1 here. So we know 1 times 1 times 1 is 1, so no need to write that. But when I multiply a to the ninth times a to the negative sixth times a to the seventh, I'm going to add my exponents. 9 plus negative 6 is 3. And 3 plus 7 is 10. So this is equal to a to the 10th power. In number 3, again, my coefficients are all 1s. And this first y here, even though there is no exponent there, we have to realize is y to the first. Okay, so we don't have to write it when it's y to the first, but we have to know that it's there. So when I go through and I add my exponents here, I'm going to get y to the 13th. Number 4 is the first one where we have coefficients other than 1. So let's go ahead and try that. So 4x squared times 3x to the fifth. So I multiply my coefficients. 4 times 3 is 12. And x squared times x to the fifth would be x to the seventh because I add my exponents. In number 5, 5x squared times 6x to the fourth. I'm going to multiply my coefficients. 5 times 6 is 30. And x squared times x to the fourth, I would get x to the sixth because I add my exponents. Number 6, we have 3 monomials. Now, one thing that I want you to realize is when you're multiplying monomials, they do not need to be like terms. Okay, hopefully you've realized that already in the examples we've done. And so if you were being asked to add these 3 monomials, you wouldn't be able to do it. That would be your final answer. But because we're multiplying, again, they don't have to be like terms. So let's go ahead and use our rule of multiplying the coefficients. So 2 times negative 5 is negative 10, and negative 10 times 3 is negative 30. And then this is a to the first. So a to the first times a to the second times a to the third is a to the sixth because I add those exponents together. 1 plus 2 plus 3. Number 7, so this is the first one where we have multiple variables to deal with. Okay, so what we do is we kind of take it step by step. You're first going to deal with the coefficients just as we've been doing. Remember there's really a 1 on this one. So if I multiply my coefficients, negative 2 times 1 times 3, that gives me negative 6. Now let's look at our x's. So I have an x to the first times x to the first times x to the second, which gives me x to the fourth when I add those exponents. Now we're going to take care of the y's. Y to the first times y to the first times y to the third is y to the fifth when I add those exponents. So our answer is still a monomial, but I'm treating each piece as a separate step. So I do the coefficients, then I take care of the x's, then I take care of the y's, but my final answer is still a monomial. Okay, so for number 9, let's see here. We have coefficients of 6, 7, and 1. So if I multiply those all together, I get 42. Now we're going to multiply our x's together. So I have an x to the first times an x to the second. Now it doesn't matter that there's no x on our last monomial, we just don't multiply any x's there. So x to the first, excuse me, times x to the second is x to the third. And then let's take care of our y's. So y to the first times y to the fourth is y to the fifth. Okay, number 10, let's multiply our coefficients. 8 times 10 is 80. A squared times a to the third is a to the fifth. And b to the first times b to the fifth is b to the sixth. Okay, number 11, multiply your coefficients. 2 times negative 5 is negative 10. Now we have 3 variables here, so let's do them each separately. So x to the first times x to the second is x to the third. Y to the second times y to the second is y to the fourth. And z to the first times z to the first is z squared. Okay, one more here. So this one looks a little strange. So we have negative 1 times negative 1 times negative 5. Well, negative 1 times negative 1 is positive 1, and positive 1 times negative 5 is negative 5. Okay, let's take care of the c's next. So c to the first times c to the fourth is c to the fifth. And x squared times x to the first is x to the third. All right, let's try some applications here. So number 13 says, find the area of a rectangle whose length is represented by 5x to the fourth z squared and whose width is represented by 2xyz. Okay, so area of a rectangle, we can find that by saying length times width. And they tell me the length is 5x to the fourth z squared. And I'm going to multiply that by the width, which is 2xyz. All right, so we are multiplying monomials together here. So I'm going to do 5 times 2, which is 10. X to the fourth times x to the first is x to the fifth. There's only one y there, so we're just going to put that y. And z squared times z to the first is z to the third. It doesn't give us any units here, so I'm just going to say units. And because it's area, we treat that as units squared. All right, let's go for number 14. Find the area of a parallelogram whose base is represented by 12g to the fifth h to the third and whose height is represented by 5g squared h. Okay, so area of a parallelogram is base times height. So I have a base of 12g to the fifth h to the third, and I'm going to multiply that by the height, 5g squared h. Okay, so 12 times 5 is 60. G to the fifth times g to the second is g to the seventh. And h to the third times h to the first is h to the fourth. And again, we're just going to say units squared. Okay, number 15. Find the volume of a rectangular prism with a length of 4a to the third b to the fourth, a width of 3a squared b, and a height of 7ab to the sixth. Okay, so for a volume of a rectangular prism, we use volume equals length times width times height. And let's see, we're given the length is 4a to the third b to the fourth times the width, 3a squared b, times the height. And we're going to multiply those three monomials together. So 4 times 3 is 12, and 12 times 7 is 84. A to the third times a squared times a to the first is a to the sixth. And b to the fourth times b to the first times b to the sixth is b to the 11th. And because this is volume, we're going to label this units cubed. Okay, one more application here. Find the area of a triangle whose base is 9x squared y to the fourth z to the fifth, and whose height is 4xy to the third z squared. Okay, so area of a triangle, 1/2 base times height. So our base is 9x squared y to the fourth z to the fifth times our height. Okay, so we can treat 1/2 as a coefficient. So 1/2 times 9 times 4. Well, 9 times 4 is 36, so half of 36 is 18. X squared times x to the first, that would give me x to the third. Y to the fourth times y to the third would give me y to the seventh. And z to the fifth times z squared would give me z to the seventh. And we're doing area, so units squared. Okay, so what we're going to do next is we are going to practice some questions that incorporate the three operations that we've learned so far. So adding, subtracting, and multiplying. And when you do these problems, I want you to make sure you're following your correct order of operations. Okay, so we're always going to do our multiplying before we do our adding and subtracting. So in number 1, the way that we're going to solve this is we're going to multiply and multiply, and then we're going to add last. Okay, so let's multiply 2xy times negative 4x squared. So multiply our coefficients, we get negative 8, and then x to the first times x squared is x to the third. We just have a y there. Plus, let's multiply those other two monomials together. That would give us 36 x to the fourth y. Okay, so now we would add these together. And the question is, if you think about our last lesson, can we add them together? Are they like terms? And in this case, they're not. Okay, so they would both have to be x to the third y or x to the fourth y in order to add these together. So since we can't add them, this is our final answer. Okay, let's look at number 2. So I have multiplication, subtraction, and multiplication. So I'm going to do the multiplication first. So my coefficients, negative 3 times positive 3 gives me negative 9. A to the fourth times a to the negative second gives me a to the second. B to the fifth times b to the negative third, if I add those, I get b to the second. Minus, now let's multiply the other two monomials. 2 times 7 is 14, a to the second. B to the first times b to the first is b to the second. And now we see if we can subtract. So ask yourself, are these like terms? Yes, they are both a squared b squared. So go back to your rules for adding and subtracting. We're going to subtract our coefficients. Negative 9 minus 14 is negative 23. And here's where you need to remember your rule. When you're adding and subtracting, you keep your exponents the same. So this stays a squared b squared. Okay. All right, number 3. So here I have some subtraction and some multiplication. So we're going to take care of the multiplying first. So this monomial that's out front, I'm just going to bring it down because I don't need it yet. Okay? All right, so negative 4 times 6 is negative 24. So since I have a minus negative 24, I'm just going to change that into a positive 24 right away. X to the third stays the same because there's nothing to multiply it with. Then we have a y to the first times y squared, which is y to the third. Then we have a z to the fourth times z to the negative 1, which is z to the third. Okay, so then I'm going to add these together if I can. And if I look carefully, they are not like terms, which means I can't add them together. So this is actually my final answer. All right, one more like this. So this one again, we're going to start by multiplying. So 5 times 8 is 40. R to the negative third times r to the sixth is r to the third. S to the fifth times s squared is s to the seventh. And then I'm going to bring down the rest of the problem. And then we're going to add. And we can actually add in this case because they are like terms. They both are r to the third, s to the seventh. So again, the rule is to add your coefficients. 40 plus negative 9 is 31. And we keep our exponents the same. R to the third, s to the seventh. And that's our answer. All right, hope you guys are hanging in there. We have one more to go. We are being asked to find the shaded area. So we're given the dimensions of this big rectangle and then the dimensions of this small rectangle. And basically, if you think about it as the small rectangle is being cut out of the big rectangle, and I want to know what's the area that's left over. So the way that we do this is we find the area of the big rectangle, we find the area of the smaller rectangle, and then we subtract the two, and that gives us the remaining area, the shaded area. Okay, so let's go ahead and start with the area of the big rectangle. So length times width. So the length is 15x to the fourth y squared, and the width is 5xy. So when I multiply those, 15 times 5 is 75. X to the fourth times x is x to the fifth. And y squared times y is y to the third. Okay, so the area of our big rectangle is that. All right, now let's find the area of the small one. So still length times width. And now I have a length of 4x to the third y times 2x squared y squared. All right, so 4 times 2 is 8. X to the third times x squared is x to the fifth. And y times y squared is y to the third. Units squared. Okay, so now that I have the two areas, again, to find the shaded area, we subtract them. So I take my big area and I subtract my smaller area. Okay, so can we subtract them? Yes, we can. They're like terms. So 75 minus 8 is 67. And when we're adding and subtracting, we keep our variables and exponents the same. So this would be the area of the shaded region. Great job!